So, okay, so good morning, everyone. Let's start our first lab today. And so today we are going to introduce three things. So firstly, we'll introduce online programming software called Colab. And secondly, we'll give some revision of the Python basics. And then in the end, we will introduce the NumPy library in Python. So firstly, let's talk about Colab. And yeah, so at the beginning, for the code today, you can download from the OLE, the Lab01 and Lab01B. So Lab01 is about the Python basics, Lab01B is about NumPy. And I'm not sure if you've been used Colab before. So it's like an online Jupyter notebook. And you can do Python programming without setting up the environment. So it's more convenient. And also, if you have never used it, please just sign in with your Google account. I mean, if you don't have a Google account, you can use any email address to create one and then sign in to access to the functions of Colab. Okay, then, yeah, please, I'll give you like 7 minutes for you to log in to the Colab, and you can simply just search Colab in this Chrome. And then the first one will be Google Colab. You just need to click and just sign up. Oh, this is the not free version. Wait. This is for the service. Yeah, you just need to open Colab here. And then if I have not signed in, then you just click sign in here. And then you can choose your Google account here to sign in. And then after you sign in, there will be some welcome page here introducing some functions of Colab. And actually the main thing you need to know is that, so the first thing is that to upload our task today. So upload the notebook because the files you download from the OLE here are all in the Python notebook format. So you just need to simply upload, click upload, and drag the document today. For example, the first one, Python basics, open, and it will upload it. It will create a new Jupyter or Jupyter, doesn't matter, notebook for you. Yeah. So anyone has problem in this part? Okay, then if everything is well, then let me introduce a bit about how to use the collab. So firstly, like let's first try it on a new notebook. You can create a new notebook in your Google Drive. That means everything will be saved in your Google Drive. And then you can see the first block, there are two different blocks in Collab. So you can choose either coding block or text block. So, like just namely coding block is like you can type code here and run it, just click this run button. And also like text block is just like you can insert some text for reference, like for comment or instructions. And it supports both the Markdown format and the LaTeX, like what we are doing here. So you can edit your text here to give some explanation or instructions for your code. This is called something like a documentation. So actually this is quite important during your coding because because once your program growing bigger, then you might forget what your code represents for, and then you can write some comment or instructions below to give some explanation for yourself to understanding or for others to understand. Yeah, so that's the two blocks. And then one reason that we use Collab here is that it provides you free access to cloud computing. So every time you upload or create a new notebook, you can use edit here. Click edit here, and there's a notebook setting. So here, of course, you can choose different language. It supports Python and R. So we will use Python 3. And here some GPUs and TPUs that you can use. So like for the free account, you can choose this T4 GPU if you need. But yeah, for machine learning, I think it's fine. But later, if you want to do some deep learning, then you need a GPU to train the model. Yeah, and you just need to set all the functions you want. And if you pay, if you buy the membership, then you have some other options, better GPU and high RAM. But yeah, if you are using the free account, then they don't provide this kind of service. Yeah, and after you set everything here, you just need to click save. Okay, then after you have set up the things you want, you just need to, actually you can directly run the code here. And it will automatically connect to the computing engine. Or you just connect here. You can choose, you can click connect here. So here you have a connect option. And also, then you can see some information here of the RAM and disk. And if you connect to GPU, you may have more information about GPU. Okay, yeah. So you can see for the code block, we just need to simply click the run button, or you just need to use Control Enter, Control plus Enter for Windows, and for MacBook, you should use Command and Enter. Yeah, and then you get the code run. Get code executed. Okay, so any problems here? And then, yeah, if you got prepared, let's go ahead for some revision of the Python basics. I think you learned it. I mean, yeah, I think you are very familiar for Python. So firstly, it's like, usually we start with the hello world. Yeah. So we can define a string and print it out. So nothing new here. And here are the different types that you can use for different symbols. Like this is called something like conversion. You can use this conversion inside the print function or statement to define the output format. And then, yeah, here's an example of this kind of conversions. So if you put, let's say we have an input number of 18, and here D means the actual number, F means the float of the number, O means the octal equivalent of the number, then X version with X and this exponential equivalent with E. So this is all the output here. That's a demonstration of using print. Yeah, and also you can combine like two strings together to output together. You just need to use a bracket here and put two strings here. So then the output will be like this. So we have the initial string hello here, and then we concatenate two strings on it. Sorry. And then we'll create a new string, which combine all the strings together. And also we use this new line symbol to create a new line. So every time you use this new line symbol, it will create a new line and print the things in the new line. Yeah, so these are very basic things. And also by default, we have 6 decimal. Oh yeah, okay. So by default, float is 6 decimal. So no matter how many decimals you have, when you print out, by default, it is 6 decimal points. And then you can define the points of decimal points by the number here. We just need to put dot like 5, then it will be 5 decimal points. And look, let's say if you put 4 here, then it will be 4 decimal points. And then you can also do some alignment. So let's say in total you have 9 spaces. And then you want to have an output of 5 decimal points. So it will automatically compute how many space should be at the beginning. And also, yeah, you can use left alignment too, I think, but yeah, sorry, I forgot the, not like this. Left decimal. Yeah, so this is, sorry, left alignment. So you can use both left alignment or right alignment. So by default is right alignment. And if you put a minus here, then it will be left alignment. Okay, then you can also use padding to put zeros in the blank places like this. Yeah, and then let's talk about the data structures. So firstly, we have list, right? So we can store different type of data in list. And let's say if you want to define list, you can simply use this square bracket. And then you can also use this type function to check the type of the data and then print it out. So once you are checking the type of a variable that we defined here, then it told you it's a list. Okay, so yeah, as I've mentioned that you can put any kind of data inside the list. So it is, yeah, I mean, it supports different type of data in a single list. You can even put a list inside the list. And then let's talk about the set. So this set is being used to eliminate repeating numbers in the sequence or the list. So we can have a look at the example here. So for example, we have 1, 2, 2, 3, 3, 4, the list here. And if we use set, then it will eliminate the repeated numbers inside, and the output will be 1, 2, 3, 4. And also there are some built-in functions for set. Let's say we have two sequence, 1, 2, 3, and 2, 3, 4, 5. So we can use the intersection to get their intersection. Yeah, literally. So we know that the intersection of these two sequences are 2 and 3. And also we can put them together, combine them together. So, but only, I mean, when we combine them together, they will eliminate the repeated number. It's like union. And we have 1, 2, 3, 4, 5. All the elements appeared in these two sequence, two lists. And also we can use remove to remove a single element inside the list. And also clear, we just clear all the elements inside the list. It will be then an empty set. Okay, yeah. Then let's talk about the control flow statements. Actually, all easy things. So, like first, the conditional statement if. So you just need to how to say? I mean, nothing special here. You just use if and put the condition here, and then follows with the code that you want to execute in this condition. So, for example, if x is minus, I mean, greater than 10, then it print hello. And also you have if else statement and if else if else if and else statement. Yeah, you can put as many else if as you want inside this logic. And also then for loops. So here, one thing you need to notice here is that range 5 means from 0 to 4. Okay, so this is quite important. And also, like you have while loop. So the while loop is like you put a condition here. And then if the code meets this condition, then it will execute the code inside. And until until, for example, here, until I is over 3, it will go out of the loop and then execute the following code. So it will be something like this. And also you can force the loop to break just with a break statement here. So yeah, you can also put some conditions for break. For example, here you put a range of from 0 to 99, but once the I is over 7, it is break. So it will only print it's over or equivalent to 7, it is break. Then the printed sequence will be from 0 to 7. And also continue. Yeah, so continue is like it will directly go to the next loop or the next cycle, and it will ignore the code after the continue. So we can see like this. So here, it doesn't print the number 5, 6. So if we comment this continue, then we can see it will execute both this part and this part. But if you use continue here, then every time it executes this statement, it will ignore the following statement and continue to the next loop. Yeah, this is how you use continue. And also you can define some functions. You just need to use this define and then the function name. You can define some arguments inside. It can also be empty. If it's empty, then you don't need to put anything when you call this function. And if you define some arguments inside, for example, you put a username, then you can use these defined arguments inside your function to make the function more flexible with the user input. Yeah, so if you define the functions, then, if you define the arguments, then you need to put arguments when you call this function. And there's also some other ways. For example, you can put another argument, let's say x, but you can give some default number. For example, x equal to 1. So like in this way, we see that you have two arguments inside your function, but when you call your function, you don't need to put both of these functions. You don't need to put both of these arguments. You just need to define one because the second argument, it has a default value. However, if you do like this, it doesn't have a default value, then when you call your function, you must define all the values of the arguments to use this function. Yeah, this is also an important part of how you call this function. Because you might meet a lot of functions later that they have different number. The same function, sometimes you use like 2 arguments, sometimes you have 3. You use 3 arguments because they have defaulted value when they define these functions. Then it will be more user friendly. You don't need to define all the arguments. They define some good parameter for you already. So that's what it is, right? Let's go back. Yeah, so this is the original code. Okay, yeah. Yeah, of course, the function can also have some return value. So in this way, you can give this returned value to some other variables. For example, you define return z here. It's the multiplication of x and y. And then when you call this function, you can directly give this value of the function to another variable c, and then print this c out. So c equal to the result of this function. And also you can have multiple return value, like return z, let's see, w is equal to x minus y. And then you can cd print. Yeah, so you can also, like, a function can return multiple values. And then you can give this value to different variables according to the order. But one thing you should notice here is, I think it's like this. Yeah. For example, this function have 2 returned value. Then when you give value to other variables, oh, this also work. Okay, then maybe Python is a bit different. See. Okay. Yeah, so if you, it will automate if you define 2 returned value, but you only give this value to a single variable, then it will automatically convert it to a list, I think. Yeah. Okay, doesn't matter. So let's go back to the original code. Oh, no, we can check it. Wait. CW. Let's see, print type, RP type. See. Oh, okay, yeah, it's a tuple. So like, yeah, so it has multiple values, then it is a tuple. So if you, yeah, sorry, I just made a mistake. So when you have multiple return values in a single function, and then you only give these values to a single variable, then it will automatically convert this output into a tuple. And also, then let's talk about this lambda function. So the lambda function means that you don't need to define, this function, when you define it, you can define without a name. You don't need to put a name like here. And it can take any number of arguments, but can only have one expression here. You cannot put multiple expressions like in these kind of functions, in the normal functions. So let's say, here's an example of a single argument. And let's say if you have multiple input like x, y, z, then you can do like x, y, x multiple y and multiple z, multiply z. And then when you are using this function, you also need to put the same number of arguments. Let's say 1, 2. Okay. Then it will automatically, not automatically, but it will calculate the multiplication of all these three inputs. So that means you can take any number of arguments as more as you want. But you need to define here lambda, these arguments, and then expression for these arguments. And then if you want to use this function, you just use this z and put these arguments because you define the name, define the variable as z here. Define the lambda function as z here. So you just use the z to call this lambda function and put all the arguments to use the expression inside. Then it's about classes. Yeah. So a class is like, you can define some initialization. So when you instantiation these classes, instantiation means 实例化. So usually when you have a class, you need to, when you want to use it, you need to first create an instance for this class. So this means instantiation. And once you create this instance, the initialized, you should define some initialized value here. So this initialized value should be the same, will be conveyed to the values here, name and symbol. For example, 5, and the string 5 and the number 5 will be the name and the symbol here. Yeah, we'll just look at this example. So we instantiation this EG4, and then we can use the functions inside the classes. For example, the square function, the cube function, and the multiply function inside all the three functions with defined here. We just need to use a dot here. So this is the instance of the class. So instance dot functions. And these functions, you can also have arguments. And when you call these functions, you just need to put arguments inside, and this will be the same like how you use the normal functions here. And one thing is that, yeah, when you define a class, and you might use the variables inside this initialization. So you need, when you use, if you want to link these two variables together, means this, to tell the class these two variables are the same, then you need to put self here. So if you put self here, then it means that this variable is from this initialization function. And yeah, then when you call these functions, it will automatically get the value of this variable inside this function from the initialization function. This is how class work. Also, if you say you don't want initialization of the, you don't want any initialization values, you can also delete it. You just want some different functions inside the class. Then you can also do like this. Let's see. Yeah, and also for each function inside the class, you need to put self here to use the initialization value. Also to call the function inside this class. And yeah, so it's like this. If we create a new class like this, we don't need initialization values. You can just delete it. And then, so let's say, because we define some values here, we just do some random value, doesn't matter. No attribute symbol. Yeah, sorry, because we didn't use this one. X. We just did it. Doesn't matter. X. Oh, this one. Yeah, if you don't want to use any initialized value, then you can do like this. Sorry, I forgot to create a new instance. Yeah, and then it will be something like this. You don't need to put any initialization value when you instantiation the class. Okay, so these are all the review for the basics of Python. Do you have any problems? Okay, if no, then let's go ahead to, I think I've taken so much time on this part. Let's go ahead to the NumPy. So as what we did before, we just upload the NumPy notebook. Okay, so NumPy is actually like a package of something like to manipulate arrays. And like the main advantage of NumPy or for the ND array is that it can only store the same type of data inside. So the calculation of ND array is much faster than list, because when you're doing calculation, you don't need to check the type of the data inside. So yeah, as it said, right? So like a Python list we used before, it contains different kinds of data types. And NumPy can only hold one type of data, and therefore doesn't have to check the type of data every single element in this array. And so this NumPy array is very useful for your following, assignments or project, because I think all the data or all the input for your machine learning model will be converted to NumPy array first for further processing. So let's see how to create NumPy arrays. So actually, you just need to use this function, NumPy. So firstly, you need to import the NumPy library. So you just need to import NumPy as NP, something like this. And this library is, defaulted, installed in this Colab, so you don't need to install it. And if you want to install some other libraries in Colab, you can just use this like this. And then put the name of a package, for example, NumPy. Oh, sorry. I've installed. NumPy. Yeah, something like this. And you know, like because NumPy is already installed, so it said requirement already satisfied. And it has the version here. Okay, then how to create an NumPy array? It's very simple. Like we just need to use these two brackets, square brackets with the elements you want, and then convert it to a NumPy array type. Yeah, so it'll be like this. And also you can create an array of all zeros. It depends like how many zeros you want inside. So if you want 3 zeros, then it will be like this. You can also create a like 2-dimension array like this. So it will have 2 rows and 3 columns. So, but please notice here that you need to put the extra bracket here, okay? And also the same thing that you create an array of 1. So you may have questions why we need to create something like an array of zeros, because later, like for machine learning, you might sometimes need to initialize some values of the parameters. And usually we initialize it as 0. So you can do like something like this. And yeah, so for this function, it's also the same. You can create different dimension. Yeah. Also, you can create a random array like this. So it's like 3 values between 1 to 9. So please make sure, notice that in Python, all the left part is closed interval. Right part are all open interval. That's why 1 and 10 means from 1 to 9. And you can also create a linear space array with a certain interval. Yeah. And also you can create a 2-dimensional array if you define more list inside like this. And also some random arrays. So 3 rows, 4 columns, random array. And then, yeah, something like this. We can create a 1D array. And let's create, for example, here, create a 1D array of 1, 2, 3, and a random array with elements from 0 to 9, which is the 3 by 3 array. 3 rows, 3 columns. Then we can check the shape of A. So yeah, so this command is very important in the following courses. You need to check the shape of your array. You need to be careful when you are using these kind of arrays in your machine learning algorithms, because every time you need to keep that input to the next process has the same dimension with the output from the previous process. So yeah, this is like shape dimension consistency. It is very important in machine learning. And also, yeah, we can check the size of the arrays that we created. We have 3 elements in the first array, 9 elements in the second. And here's how we do indexing of this kind of array. So we just simply put the order of the elements we want. For example, 0 here means the first elements. And -1 means the last elements. So we can see, firstly, we can see what is A, right? 1, 2, 3, and the first element is 1. The last element is 3. And also slicing. Yeah, let's see, we create array like this. If we want to get the first 2 elements, we just need to use this 0:2. So it means you get the net elements from 0 means the first elements, 2 means the second elements. Sorry, yeah, 2 means the second elements. But again, this is open interval. So actually it means from 0 and 0, 1. So it doesn't contain 2. That's why it means 0 and 1 means first and second. So it just get the first 2 elements. So this 0, 2, 0 to 2 means 0 and 1. So also, if you want to get the number 3, 4, 5, you just need to put there 1, 0, 2. Yeah, 3, 4, 5. So 2 means the third element. 5 means the 6 elements. So it's from, yeah, so it's like here. 2, 3, third, fourth, 2, 3, 4. Yeah. Okay. Yeah. Third, fourth, fifth. So actually, so yeah, again, 2 here means the third one. Okay, 6, 5 means 6, 1. But this is open interval. So it's 3 to 5. 3, 4, 5 here. It is quite confusing sometimes. And also you can get odd number like this and even number like this. So actually it's just omit the interval here. It's the same as like from 1 to 10. From 1 to 10. I think from 0. Yeah, to get odd number. And then to get the even number, it's also like this. Okay, then also we have a function of reshape. So we can reshape a sequence into a shape that we want. For example, we randomly, we create a array from 1 to 9, then we reshape it to a 3 by 3 matrix. Then it will be like this. And yeah, so for a matrix, we can also get like the first 2 rows and the first 2 rows, yeah, the first 2 rows and all the columns. So when we omit the columns here, it means all the columns. And broadcasting. So it's like when you are having different dimension of arrays and you are doing operation between these different dimensions of arrays, the array with smaller dimension will be adapted to the same dimension as the bigger dimension array. and then do the operation. So it's like 5. If you have X here, this is array like this, and you have a single number of 5, broadcasting means it will increase the dimension of this 5 into the same length of this sequence. So it will create like 1, 2, 3, 4, 5, 10 fives in total, a sequence of 10 fives in total, and then add them together. Yeah, so it's like this. And also you can do add two different arrays together. Okay, then sorting. Sorting means to organize them. Yeah, sorry, not this one. Yeah, this is sort. To organize them into, from small to big values. And for a matrix here, you can sort according to the dimension. So like it sort this like 3, 3y, which is 5. Dimension 0. Yeah, so dimension 0 means this column. Okay, so the first column, because all the values are the same, so you don't need it, no matter how it's sorted, 3, 3. And then the second column, it will be sorted to from 2. The smallest is 2, so it's sorted from, you put the 2 to the first row, and then 3, 3. You can see from the column direction, it is from small to big, it is sorted. And also 1, then it's like from the row direction. And you can also get the use a conditional statement here to check if the elements inside the sequence meet this condition. And if it meet this condition, then the input will be, the output will be true, or it will be false. And with this statement, if you put it back to the array, then it will print all the elements that meet these requirements. Also, if you, to be more complicated, you can put 2 different statements here, and then it will check the elements inside this array to give you the output. Yeah, the final part is reshape. So if we already have an array, here is a 2D array, and we can check its shape. Its shape is 4 by 4, and we can reshape it into a 1D array. So this is -1 means it will automatically calculate what's the dimension of the output array, like this. So if we we define this number of columns, and we put a -1 in the row part, then the function will automatically calculate the number of rows should be. So it would be like this. And then if you want to have an array of 4 columns, then you can do like this. And also if you want 4 rows, then you just need to do it in the opposite way. 4 minus 1. And it has the same, it is equivalent to 4 and 4. Because it's automatic. Yeah. Okay, so this is the end of this class.